So let's just start a new project. So a lot of what's fun about these game engines is we've talked about collisions and whatnot, but also using physics. And what's interesting about physics simulations is they kind of they're different almost every time. It's a really organic way of adding some sort of kind of character and procedural nature to your animation, dropping things, throwing things, hanging things, all this kind of stuff. And I'm just going to show you a few ways to kind of set that kind of stuff up. And a lot of you I've seen it have found destructible meshes and whatnot. And last week, of course, I made a chair drop. It wasn't groundbreaking by simulating physics. Right there, and then hitting play. There you go. So as you can see the settings here, it has a default value that it gave it in kilograms when I imported it or when it was imported, and you can override that if it's falling too fast or too light. It has some dampening so it doesn't fly as far, and if you take away gravity, you can make it fly away, float. Let's see. And that's how you do a space scene. You can also constrain it if you don't want it to go on some axes or whatever. If you don't want it to go on Z, but you want it to go on X, you can always do these constraints and everything. And then you can also create triggers from that. You can make it simulate hit events or overlap events when it actually does something. What's kind of cool is that we have physics materials we can either make from scratch, or I'll just kind of bring one in from the contents example. I steal a lot from the contents example. You just search for everything of one type and you send it somewhere. I send it to the project you're working on. So I am going to just look for physics materials by filtering. And materials. Yes, it's going on your permanent record. And look, I have all these things that say wood and rubber and metal, and I think we have an idea what these things are going to do. So I'm going to just take all these assets and I'm going to migrate them to my week 10 folder and contents. So I'll just minimize this for now. And then I can also filter it here. I know it's probably going to be in the example content and physics materials. And there I have a slick rubber rocket. I don't know what a slick rubber rocket acts like, but if we select here, we might be able to choose it and see what happens. So I've added a physics material, and we're going to see how that happens. Well, that looks exactly the same. Let's do a rubber ball, or wood, rubber. It does the same thing. So that's a lot of fun. It's doing the same block ball. Let's move it over. So it's not on the table. Okay. All right. Kerplunk. Anyway. These things actually do work. Just doing something wrong. So what's great is that you can actually set up some physics simulations at the very beginning of your scene and play them out and see how they fall. So I'll put this one too. Simulate physics. And so now when I play, this one falls, that one falls, and I kind of like it there. So I can actually right-click on this object or find it over here, or whatever, the table, right-click on there, and I can say, keep simulation changes. So now I've created a simulation that will now stay there, let's see if we can say it, for when I stop it, it should be there, and there it is. So I did a physics simulation. If you want to create a pile of things, You don't want to have to actually place them. This is a great way to create clutter, to create a cool scene. And then, of course, it still has physics and simulating anyway, so I could then jump up and knock it over should I want to. You can also do this kind of stuff in, you can enable physics in blueprints as well. It could be a trigger, it could be a button, it could be a slider. But what I'm going to do is I'm going to find another object that I didn't really know about until recently. It's called a Radial force actor. So I'm going to bring this little thing in. It's very small, but then it has an offset. And what this does is it either has a constant force or it has an impulse. So you either can push things out continuously, or you can have one frame of a hit to make an explosion. So you made this pile of rubble, and you want a hit to happen, you want an explosion to happen. You can actually trigger this impulse value and send things flying. So I have it above there. I have the table above there. It's staying here. And I'm going to go back to my table. My table has a default mass of 145 kilograms. Anyone know how to convert that to pounds for me? It's 2.2 pounds. So do you think, I think it probably needs more, right? Oh, one kilogram is 2.2. Yeah. Okay, so it's like 300-pound table? Well, whatever. We're just going to blow it up, so it doesn't really matter. So, so I have the radial force actor, and I'm gonna make it not working at the beginning. I want to take off auto activate, and with it selected, I'm gonna go into my blueprints, and I'm just gonna put on a key press. So, I'm gonna create a reference to the radial force actor, go into that node, and I'm gonna fire an impulse. Boing. So I'm firing an impulse, and I'm just gonna put it on the O key. There's our O key, and when I press it, it's going to fire this impulse. And I'm going to compile and save. Now, one thing I think we talked about a little bit during the lighting week was that we have to actually, when we're going to move things, we have to let it know that it can be moved. So when I made this table simulate physics, it moved it to movable. But this chair next to it, I haven't set it to simulate physics. I would have to make it movable if I'm simulating physics within the blueprint. So it'll give you a warning if I actually also take this chair and create a reference to it and try to actually simulate physics and saying, yes, I'd like it simulated. I would actually need to make it movable first before I did that. I'm not really going to hook that up to anything for right now. Now, what's really crazy about this force is that its impulse strength is 1,000. Who knows what unit that is? And it has a force strength of 10. We're not going to use force. We're going to zero that out. I am going to say that the radius is big enough because it's definitely within the radius. Yes. So we just want to see this thing go. But I hit hitting O and nothing's happening. And I know from previous experience that 1,000 is not much at all. I've actually been using values into the millions to get this going. And that took me a long time to like slowly increment up to 1,000,000 for whatever unit that is. So with it simulating, it's going to fall down in here. And let's see if that was too much or not. There we go. That's a punt. Maybe 1,000,000 was a little bit much. Let's see if I wish. Can somebody model me some field goals? All right. Yeah, right. So, yeah, I'm going to go over. There we go. I'm going to send it over to Dylan. Punt it. Catch up to it. No, it's gone. It's gone. So that was obviously a lot. But yeah, right? Oh, I have a whole thing of starter content. But you could also say this is why we don't have nice things, right? Content. All right, so I have all these physics simulations. These are great. I love these. Things are happening. But I want to actually play around a little bit more with some other items in here. So I am going to take this chair. Well, this chair can continue simulating. It seems to be having fun. doing its thing. I'm going to take this chair that's static. And so if I hit play, this chair, that's, even though it's in the air, it's just going to stay there because I haven't simulated physics on it. So I'm going to move it on top of this table. And I am going to add a constraint. Constraint. There we go. Physics constraint actor. All right, so this actor is right here. And I'm going to kind of just put it halfway between these two guys. And then I am going to have it select over here. And you look over in the details panel, and it says constraint actor 1 and number 2. So if I go back to this chair, and I go to drag it down, oh, I can't drag it down. I'm going to go back to the physical constraint actor, and over here, right here at the top right, it locks it. So now it's going to stay open. I can go back to that chair, and it's still the detailed panel for the constraint. And there it is. It's one of the first actor. It says chair, and the table, the second one, and there it is. And then I can take off the lock, and let's hit play. Oh wait, I have some more values I'm going to look at first. So physical constraint actor, if I go down, it has 3 presets. If I hover over them, you have a hinge, which it means it only moves on one plane. Prismatic, which I didn't know what that was, that's sliding, linear sliding. And then ball socket, where it can go on all axes. I'm going to hit play, and I'm going to see now it's constrained. And this is how you can make like swinging lights. You can put light sources in there, create nice environments, and every time it will kind of just have its own procedural movement. And especially when you try to impulse it out. So that's really gratifying. I wish I could have gotten the bouncing ball to work. That was frustrating. Let's see what we have. Okay, let's do post processes. Okay, so what we haven't really gotten into, except for I've talked to a few guys individually, is post process volumes. This is the last render on your video feed before it goes out to the screen. It basically affects everything as a big chunk, and it's kind of like a 2D screen over all the video, the 3D content that you have. I'm going to show you what that means in a second. It has a lot of options, and you'll have to kind of play around with it yourself. But if I double click on this post process, I see that it is a thing that lives in space that I don't see, so I'm going to delete this and make my own. Let's make our own post process volume. Post process. Let's just say visual effects. Post process volume. So this is a box. This box can either have a volume, so when you walk into it, this visual effects will happen, or they can be unbound. For right now, while we are inside of it, I'm going to keep it bound, and I'm going to start looking at the different options I have. I can obviously change the size and make it as big as I want to. I'll keep this the same size for now. And underneath this little toggle is the whole world of post-processing. Damn. There we go. These are all the color correction things you would do if you're running post. You're rendering out things. It has wonderful things like white balancing and color grading. We can take the saturation for the whole scene, boost it. This is where you can really create a signature style for your live video rendered out. You can increase the contrast, or go through all these different things. And it's, even though it says X, Y, and Z, that's really RGB. So now we've completely changed this to be like it's 80s television show or something. We can add film grain in there. My favorite, of course, is vignetting. Really add in that vignette. And then you can add in fringe intensity, which is chromatic aberration, and separate out the RGs and Bs around the edges. A lot of these things are 0 to 1, but I know because I've done many times, chromatic aberration can really be pushed. by dialing in numbers we want it to. So when I walk out though, and it's gone, it's only when I'm inside this volume, and it's got a fall off. You can turn it on off by key press. Yeah, you can enable it, disable it. And what I'm going to do now is I'm going to just like take this one, and this is like I'm definitely thinking of Anderson about this kind of stuff. Like put these guys next to each other, and as you go through your roll, I'm hitting down Alt, I'm sliding it, and now I have two side by side, and you can blend them into each other, so you can change their post-processing values as you go through. This new one, I'm going to take off maybe the fringe intensity, and then color grade it a different way, and just go saturation on one channel only. I'll leave it kind of a surprise for me. And then where is, yeah, crush highlight sounds really aggressive. I like that. I have no idea. And we also need lots of bloom. Bloom will be like overexposing white. And most importantly, lens flares. Make it look like J.J. Abrams' Star Trek. 16, no, 100. Okay. Anyway, that's enough playing around. Let's see, now it's, so I'm in here, and we got this, and then we're going to blend through it as we go across, and now we went into this world. And they kind of have a fall off. So these are kind of, render intensive, but if you're using the computer we have, it's great for handling this kind of stuff. And this can really dial in and really like sell a piece in the end. There's also depth of field, which I'll put up there. So this one, actually I'm gonna make one from scratch. This is kind of like too affected now. I'm gonna add in another volume. And just do depth of field. I'm gonna do a Gaussian depth of field. And let's go in there to really dial this in. So now we've added a little bit of blur to everything. And I could set what distance that falls at. So that's like focal distance, so near transition. Say it's only when you're after a certain spot. And you kind of want to animate this with your field of view if you're doing a field of view animation. Scale, whatever. I have problems with doing the bokeh depth of field, but yeah, now it's almost unintelligible. But then if we select all three of these guys and we make them all unbound, it's everything all the time. All three of them combined together to make happiness. I think I still have a fall off, it looks like, but we'll see. We're going to bound these back up again. And the one other motion blur is also kind of processor intensive, but that's effective for like dance moves and that kind of stuff, so that they're not too crisp. And then underneath here is the last material we'll go over in class. We've done everything, light functions, all sorts of stuff. It's called a blendable. A blendable is a material you can make as a post-process and kind of overlay it. I'm just going to take some of the starter content material and I'm just going to turn it into a blendable. So material, and let's see something that's good. I'd say that looks great. So I'm going to open it up. And all I got to do is I know that post-process only goes to the emissive color. So when I change this, not surface, not a light function, but a post-process, I'm going to move it over to the emissive color. And that's basically it. Save it. I'm going to make a new post-process. Oops. On this little stack of post-processes. Stack of awesomeness. And with it selected in my content browser, I'm going to hit the little arrow to slide it in to my blendable. So this now affects the screen. I can blend that weight down so that it transitions through. Oh, I gotta put in, sorry. Okay, let's see. Depth, texture. We just let it know that it's a post process from here as well. Something like that. Oh, other way around. Anyway, these blendables, you can make an array of them, and this is where you can VJ. You can line up a bunch of video textures at 720p, load them up there as an array, and they can play on top, or they can transition underneath. 720 is they'll fit the screen as long as you're HD, or you can crop them out. They're going to be lower resolution. Yeah, it's not until 4.11. The version number of Unreal that they're actually going to start implementing. And 4.9 came out when we started, and 4.10's in preview, and in 4.11 they were promising that we can actually handle higher HD and potentially 4K textures, video textures. But for right now, it's not the case. Let's say color. Let's do a multiply. Errors. Well, it can't all be good. I'll have a really cool one where we turn the reds and greens into UE4 deformation next week. I just didn't have a chance to memorize it. All right, so yay! It's the last. This is the last plane. Everything that's in your 3D world is going through this last plane before it goes to the graphics card and goes out to your screen. So this is the last layer. This is the saran wrap around your dinner. And so right now you're putting a piece of paper between that and you. It's a two-dimensional. This could be used to, like, we can create a custom UV texture around an environment so that, like, when you're going through a warp tunnel or it could be animated, it could be cycled, you can create kind of HUD elements that are beyond just the vignetting that comes within it. You can make a custom vignetting and other kind of visual effects for the camera. Because you blend them in. This is supposed to be slightly invisible, but it's not. Let's see. But I'm going to go over those next week in more detail and show you some cool ones that I came up with. Let's cancel that. Okay. So post-processing, that was great. All right, so let's talk about widgets. So some people might want to do scoring. Some people might want to do a heads-up display. They might want to have a menu, and that is under miscellaneous. And it's not under miscellaneous, it's under user interface. It's widget. This is a new blueprint called Widget Blueprint, and we're going to call this a menu BP and save it. And this is actually how you can create a menu interface. And you can also VJ with this as well. So this is about buttons and knobs and things like that. So we're going to put a button in here, and I'm going to resize it, and there it is. And then I can have another button there, arbitrarily resize it, or alt-click to double it over. We want to let people know what these things are. So you want to have some text there, resize that as well. It's really small, but it says something like, zoom in. There we go. So it says name slot, which I can change, and make bigger. It's really annoying. It's already together. But so we have these two buttons, and we want to do something. And just like, and this is how you make an interface for like a mobile app and all that kind of stuff. And you want to do something. So with it selected, this button right here, I now on the bottom here have events. So on clicked. on click, I want this to do something. So this is number one. And then on the other one, if I go back over to the designer, on clicked, I can have another one. So we now have two events that we can load a level. We can load a level and say which one we want it to be. We can, which will be, what's my level here? Minimal default. Photo 1 for me. We can also make a pause button. We still have that time dilation. We can pause things so that none of the physics happens, not everything is set to 0, or we can set it back to play. But we need to get it onto our, no, okay. And so we have this blueprint. We need to set it up, and we're going to set it up in the level blueprint. Nope. All right. So I need to first look for a widget class, which is add widget component. Is that it? Nope. Widget interface. Okay, so I've set select widget interface. You see it has a little screen there letting me know that it's going up to the screen. And I'm going to say on event begin play. This could be you hit escape, you go back to a menu, and this is a way to reset your level and play again. I select my class here, which I call it menu BP, and then I need to put it onto the viewport. Add to viewport. So on the event begin play, error, oh, connected there. There we go. So now let's get rid of the post-processor volume and hit play. And I now have two buttons. Of course, I don't have my mouse because that's by default gone, so I need to actually enable mouse visibility for menus. If I get my mouse back. I forgot which one was. So that reload the level? Nope. 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 Oh, do we have time dilation on now? Yeah. So, yeah, sign me up for the Whitney. Video so anyway, that's obviously a very low level, high level, high. Yeah, you can load in your own custom PNGs with transparency and make your own custom. This is the same way you would add scoring. So inside of some of this logic, you would have a variable for an integer variable for your score, and every time some sort of event happened, you would then add +1, and then reset after a certain event happened, like after the level ended. So this is how you handle all the heads-up display, all the graphics on the top end of your. Every single graphical item becomes an event trigger. If it's not going to be interactive, you can totally put it there. If it's not going to be interactive, you use it as a post-process, or if that way you can kind of blend it in with other effects. Or I think there's also just called a HUD that doesn't have an interactive element. So if you just look at make a blueprint class, and there's the whole world of blueprints we're never going to go over. But I think if you search for HUD, you're actually going to get something that will actually go just straight to the HUD. There's just a HUD blueprint. And that's if you don't want any interactivity, and it's just some sort of like text element. It's not very user-friendly. I would definitely recommend using the this widget, which is also called UMG, Unreal Menu Generator. You see it says parent class UMG user menu. So yeah, and then inside this designer, you can bring in a texture, and so these textures can be. Oh, that's right. That's the text block. My bad, guys. Image. Let's do image. So this image could be a texture. that you've made in Photoshop and brought in. Ability, color brush. There's the image. So I could choose an image, and now I have an image. It's loading that in, or whatever that is. And this is where you can also bring in video if you want to have, during your title sequence, you want to have playback some sort of cutscene that you don't want to actually render in real time. So this can be video. This can also be a screen capture from inside your world if you actually want to be generating some sort of generative thing that's happening. You can also use, we bring in a box. And then I could bring in a scene capture 2D. And this is going to be going to be capturing video from in my world. This is how, basically this was developed so you can do security camera footage. And like, if you go to the blueprints example level that's in the Learn tab of your launcher, you'll see that they have a security camera that has like one of these parented to it, and then you go to another room, and it is displaying the video with post-processing effects on it. I can always click here on there. And if the scene capture cube, this is actually getting your panoramic stuff. This is actually how you render out a 360 video to put up on YouTube 360. It does require an additional plugin, and I haven't gotten to work. I just discovered it this week, but this is a cube renderer. It's super processor intensive, and it's only really good for if you're just going to do matinee to render out the last second. Scene capture still, you can turn it off and on. So to be seen, to use a scene capture 2D, we need to actually have a rendered target. So here's our texture target. I'm just going to create a texture. How did I do that before? I need to create a render target. Materials, textures, render target, and I'm going to select render target 2D from there, and now you can see that this texture is indeed the scene capture. This could be, I could change the resolution. This is 256 by 256, and I can have more resolution. Obviously, this is a second video feed, so you're now doubling your video feed that you're processing live in Unreal. So do be wary of adding too many of these, and you can disable it when you're not using them in your scene. And then, as we know, any texture can be a material, and that material can go on any object. And so if you want to have like a bird's eye view of something, you can come down here, and now we have a live camera feed that could be also on matinee. Yeah, this is how we did the menu for the Met project. There's a bunch of these in a box living way out in the middle of nowhere. So yeah, this is cool, and there's video feedback and all that kind of stuff. And of course, we could put it in our post-processing volume and give it hell. Does it work? No, it works for us. So it's not, of course, it won't do that. Post-processing happens very, very last. This is a texture that is then going to our camera that would then be post-processed. So yeah, you can't do that. And this could also, of course, then going back to our menu, can be a texture, if I could find it. I called it target. And compile. Size constraints. Oh, it's really small. And I think I have to be playing for it to actually work. Physics day. Well, you have to take my word for it on that one too. All right, let's move it on. Okay, we're going to go back into, right before we go to OSC, I just want to kind of make another little, well, I said dialogue. I didn't mean to do dialogue. I don't know what that is. Actually, let's get straight to OSC because we'll spend more time there. So we're going to do live show control. I'm going to be controlling the events in Unreal through a controller that I have here that is sending out MIDI. I'm going to use a program called Max. You can also use a program called Pure Data. And I'm going to be sending values from here. We can do buttons, we can do sliders. And these are ways for you guys to control color changes, control all those effects on your post-processing. You can have it on audio reactive things. So I'm going to show you how to get values from here and bring them in there. So I have a new project and I need to save it, and I'm going to close out of it. And under the code examples, I made an OSC folder. It's already precompiled for 4.8. If you ever want to learn how to compile it yourself, it's fairly easy, but you'll have to do it if you're using it on 4.9 or any future versions. I'm going to take this plugins folder that has OSC in there, and I'm just going to copy it. And I am on week 10. And I mentioned OSC twice now. OSC is basically, it was invented for Program Max MSP. It is a framework of sending UDP, which is a very quick internet protocol. It's very lightning fast. It's somewhat lossy, so if you send out a whole bunch, you might need to get into data organization, but you're not going to probably get to that level in the time we have left in class. So I'm going to open up that project again, which I can do from right here. And it's now installed into the project. To confirm, I'm going to go down to Window and Plugins. And there it is, and it's enabled. I'm also going to go to my project settings and see what port it is receiving on. It is receiving on 800. I also know that it's sending on, or sorry, 8,000, my bad. It's sending on 8,000. I'm not going to do any sending today, but I could send events. You could send event triggers to all sorts of other show control stuff, the DMX lights. So your DMX lights are getting color values from inside your world, from your scene captures, so that you can do external triggers that way. All right. So with OSC enabled, I need to make a blueprint to do something with, because I need it. It's actually a component of a class blueprint. So I'm just going to say, oh, going crazy. There we go. Oh, you see, it's like stuck at the bottom of my screen. Oh, okay. Javier, can I borrow your mouse? My trackpad went complete. That's really weird. Let us see. Content there, great. Quit. There. I think I just have too many things open. Let's see if it comes back. Okay, that was it. I shouldn't have had the content examples open. Fooled you. I didn't need it. But thanks, man. You got my back. All right, so back to controlling things. Okay, so I'm gonna make a class blueprint, or blueprint class for an actor. And in this actor, we're just gonna move a box around. So this is BP box. And I don't need the scene root. Actually, I can leave it there, it's fine. But I am gonna put in a box. a cube. There's the cube. So we have a cube in the scene, but I also want to add another component, which is OSC. OSC receiver. This is another event trigger, so I need a trigger event on OSC received. And then it's going to be a trigger that's going to execute an event. It's going to come on an address, and it's going to send out a structure of data. It's going to take floats, bools, strings, just all sorts of stuff. It's just amazing. Today I'm going to make it go X, Y, and Z. So in Max, I've already kind of made it, but I'm just going to make it again. We are going to, and if you need any help with Max, there's a lot of people who know it in this class, so we can help you out on it. Don't feel like you have to learn this program from scratch. I do it in my free time. So we're going to send out a value for X. So I said it was an internet protocol. It needs to go on an address, just like a URL. And Max sends variables over $1. Variables are $1, $2, etc. And we're going to send it over UDP, which is the so hard to switch between node-based languages. UDP. So we're going to say UDP send. And then it's my local host. It is from my computer to my computer. So this is localhost. This could also be 127.0.0.1. And then we're going to send it to that port, which is 8,000. And we're just going to send it a value. And we're going to send it a value of a float, which is the F for a float box. And if I print here, open on messages, you will see how the variables work, that it is indeed sending this value over the channel X. All right, so I'm going to go back to, Max just crashed. That's great. Yep. That's why they added the recover edits version, because it is going to crash a lot. All right, so I'm going to send that value. I'm going to receive it over here. Moving on. So first we have to parse the data. Actually, first what we're going to do is we're going to tell, like, my computer's plugged in. I'm not worried about my CPU. I'm not worried about running out of battery power. I'm going to go to my engine settings, preferences, and the miscellaneous tab, and I'm going to uncheck use less CPU in the background. This is why sometimes when you check your email or something like that while you're using Unreal and it's playing, it starts getting choppy. It does it on purpose. If we get rid of this checkbox, then it will always run smooth when we have another application running in front of it. It might be important if you actually have to, like your craft work and you have to check your email while you're also playing a show. All right, back to the box. So we want to receive on the address, which is equals a name, and that address was X. All right, and we're going to use the data flow node that's called branch. And what branch does is that it executes things when its condition is true. So when you're on channel X, it's going to send a thing, but what's the thing it's going to send? Well, we're going to send a float. It's called popping a float. I'll try to show it later on, where if you send a big stack of data, you can just continue to pop the next consecutive thing over and over and over and over again and take huge streams of data that are just on one long internet address. And it's a really, really efficient way of getting data across. Then you would just send out these things to your individual things you're going to execute. But for now, we're just going to do X value. And what are we going to change? Well, we want to take this cube and we want to set its relative location. Set relative location. So when it is on channel X, it's going to go over here to the rotation thing, and it's going to just set the, let's do the Z, make it go up and down. It's also going to use these default values of 0. I can also get this cube and get its relative, or get its world location. Break that apart. And then the values that I'm not sending, I want them just to stay the same. So what I did here was I said, wherever you're at, stay there on these two values. Only listen to me on the Z when I want to control you. So I'm going to dock this, save, put it into my world. This I'm showing you how to control things, so that you guys can move things around. You can change colors, do that kind of stuff outside of Unreal. Because when Unreal is rendering, it's kind of set in its own way. You know, if you're playing a game, you can have a game controller, but we can use all sorts of things like Arduinos and physical computing and other kind of prompts. So it's a way of really increasing the interactivity of Unreal. If I hit play, if I get rid of my menu, which I don't need anymore. Camera location. I hit play. And we'll see that we moved it way the fuck over there. Like a radial force actor all over again. Come back. Alright. We saw it move, but we want to have a little bit better control. So let's actually set this up the way I would do it. So we're going to send out X, Y, and a Z to move around. And by the way, this can also be your camera. This could be a lot of other things. And we're going to send more values, like we're going to send Y, and we're going to send Z. And then we could send field of, if this is a camera, we could send field of view. We could send rotation, all these other kind of things. So we could have a potentially long list, right? So we can also do this and send our rotation values, yaw. Well, that's already Y, so we'll say yaw, pitch, and roll, and send these all in. So I'm going to save this and just doing the same thing over and over again. Very easy. Let Max uncrash itself again. So in the end, we're going to come over here to the set relative location. But I don't want to continue to do this giant stack of names. So I'm going to bypass and find the combo for this. I'm going to do a new node, which is called switch on name. So now I can hardwire those things in here, connect them over. And then if I select on here to go to the right to my details, I can add new elements. And I could say X, Y, Z, yaw, pitch, roll. I do not need a default. So then I just take this one float, and I'm going to now make some variables for these. So I have now my X, which is going to be a float, and I'm going to set it from here. I'm also going to have, I'm just going to do the Y and the Z, and we'll put it into work. Y, and then Z. I'll set it. So X is going to get some floats, and Y as well. So we're actively setting these variables, and then we just need to get them. The action's happening here. This is updating the values as executing in real time, and I can just kind of, with the cube selected, I could set world location, so it'd be easier for me to find, so it doesn't go flying off like I did last time. And I'm going to split these up. It's just a placeholder. It could be anything. This is up to you to kind of like this could also be colors. This could also be a lot of other different values. This could be audio reactivity. You know, could be a light sensor. This is just kind of for you to abstract into a lesson. I take this value, throw it in here, take this value into here, and you know, these are interactive, immersive environments. You can get a lot of feedback from these kind of things. So I'm going to constantly be polling for these new variables as I'm setting them. I'm going to compile, go into my level, and save. See what happened to my values. Sure. And let's play. So there it is. It's 0, 0, 0, 0, and it's been set there. But as I move it up, you see that I'm now moving it around. This connects the whole world to Unreal, because I can also do an object that can get audio. And as again, like there's a lot of people in this class that know this. If you want to have something done, just let us know, and we'll teach you specifically what it is. So because this class isn't long enough to learn both these things, but you're only using a very limited set of functions within here. So now I'm getting audio, and I know the audio is going to be like between 0 and 1. So I am going to scale it. It is what it says. From 0 to 1, and I'm going to make that 0 to 1,000. And then I'm just going to make it affect Z. So if I test this by turning on the microphone, I see that I now have an audio reactive cue. This could be brightness, this could be any variable that you can set, and that is, you know, effective feedback. So we can do the rotation, we can send things all these other different kinds of ways. And we also can knock over that. Let's move it over. Let's move it over. And let's play with that physics actor. Well, that's gratifying. That's cool thing I've done all day.
So there's this really, well, it's not free, but there's this app called OSC in the App Store and also Android, where you basically download, create a basic wireframe with your buttons that will be your controls, and that can go into that. So aside from OSC, it's just a way that you can connect directly from your phone or your iPad into Unreal as an option.
And it costs like what, $4?
$4.
$4. So really quickly, I'm going to show you how to grab MIDI. That is another object called CTL in, and basically MIDI also is another concept we're not going to go into too far, but it's basically it's values from 0 to 127 sent on channels. So I'm going to just kind of pull for a knob on my controller. And this controller is mine, but it lives in this in the mocap room. Anytime you guys want to borrow it or use it, if you want to use it for your show, go ahead and claim it. So now I'm going to take just a knob, and as I dial it around, I see that this is channel 16, and it's going from 0 to 127. Okay? So now I have this on 0 to 127, channel 16. If I don't want to get, but if I do another one, it's going to move to channel 17. So I want to kind of declare that this one is going to be always channel 16. So I can say Control N is always 16. So now I'm moving 16 and it works, but if I move 17, as I'm doing right now, it's not working anymore. I can now add a bunch of these values and parse out these different values to do different things. This could go to my yaw, and then 17 could then go to my roll or pitch or whatever. I don't think I hooked those up, so I'll go to the other ones so we don't waste too much time. So now I have an audio reactive Z, and I can move things on sliders. These can also be buttons. So now I'm moving it with a slider. Talking, sliding. I just lost connection. I think I just unplugged it. But anyway, it was working a second. Oh, connection gone. Again? And that's the moment that something happened. Okay. Well, good thing we were done. Who knows? Yeah, no, just the connection. I have to like, what I'll do is just like open it, select all, get rid of it, and then reestablish the port. Testing. Goes here. Do it again. Or maybe I didn't compile my box. It's actually really fun. If this was working, let me get hit play. It's really fun to watch this kind of stuff get parsed out. Whatever. You guys saw it. Proof. It exists. It's a thing. We can do that more. It's fun. I'll save this and I'll put it. Oh, crashed. I think it's the screen recording software. It's really taxing everything right now. So we're going to dive into for the. Oh yeah, look at that. For the last bit of week 10, we're going to dive into a couple more particles, just for fun. And yeah, Rudy, just let me know when I'm doing something stupid. Or not as cool as it could possibly be. So particles can be very subtle. They don't have to be like an immense like visual overkill. They can just be accents. They can be a little bit of dust, a little bit of this or that. I'm going to import some actual PNGs. So last week, I didn't get a chance, or 2 weeks ago, I didn't get a chance to show you that I had this elaborate Alice in Wonderland thing I didn't get to touch on, but I was going to recreate the Caterpillar song. Yeah, it was an inspired lesson plan. That's what I get for trying to come up with an inspired lesson plan. Really? I didn't even know about it at all. This is the scene. So I thought it'd be fun to make those guys. So all I did, these are just text letters I made as 128 by 128 resolution images, and I used Comic Sans actually, so just get used to it. Hey, it's like retro now. Um, yes, yeah, it is. So I'm going to create a particle texture out of Javier. What's your favorite letter? What's your favorite vowel? F is not a vowel. All right. Put you on the spot. My bad. My bad. I'm bad. You're a plant, but you weren't prepped. So I'm going to create a material for E. Um, so E is close to F, and we know that we want to have a transparency. So I'm going to select the material base node, and I'm going to make it mask. I would do translucent if I want to have a gradient. I'm going to take the alpha off there, and yes, indeed, F there. I have E. It's not double-sided. I can make it double-sided. It's not really necessary for particles. Particles always face the camera. But what I do need to do, though, is I need to, if I want to change any parameters, which I won't get a chance to do today, I did it last time, I need to make sure that I put in particle color in the material so that it can be accessed from Cascade. So particle color, and you just blend in by multiplying the color values and the alpha values. And also, I mean, this doesn't have to be, this can also just be, you know, emissive. So it's bright and it glows, and I could change it colors here, or I could change colors and make it super glowy. We can just do that right now. So from here to here, and as we all know, this could be overdone. That's not overdone. That's tasteless. There we go. So I'm just going to make one of the textures for right now. I'm just going to make E, save this. There we go. Right? The E was Photoshop. I just did a letter. That's all I did. I just the text tool and put a letter. Yeah. And export it as a PNG, which carries transparency. So particle system's right here. I right-clicked, and this one's going to be PE, not the class, just the particle system. And so it starts off just this little emitter in the world going up. That's actually fairly close to what I wanted to do, but of course it doesn't look the way I want it to look. So I'm going to first of all change this to a type data. I'm going to make this a GPU sprite. And there's no fixed bound, that's great. And then I'm going to go to the required, because it's required, and I'm going to choose that EMAT. Compile shaders. There we go. We've got an E. But I want, so hold down shift and you control down all these, a lot of little dongle things. So particles all about being like organic and having different variables. So distribution float uniform means I want it to either last between 5 or I want it to last between 25. This is a way of getting a little bit of variance. If you want it to be exact mount, you can just say that it's uniform, and then it just gives you a constant, and then it gives you just one value that can always be. But because I want to make it over the course of a different lifetime, so it's kind of, you know, trippy snowflakes do that kind of stuff. And there we go. So now we have a little bit of variance. I can say that, so that's my lifetime. I can say my rate. So my rate could be a lot more. I'm doing GPU sprites. I can definitely just say that it's, I don't know, 1,000, 10,000. Yeah, this is a very dense module, and if I right click, you can see there's so many things you can do to these things. Like I can add in drag. A little bit of drag will make them not go straight up. 0.5. But I also can't see them because I made too many. They're kind of wavering a little bit. Let's make it more like 1. And let's see the initial velocity is going up at that speed. If I also wanted to make it the other way, I could say negative 100, and here's how you have control of where it's going. Negative 100 to negative 1000. And now you can see that I'm going to be shooting them off like a waterfall. F. There we go. There we go. But I like my let's turn these into snowflakes. Happy little snowflakes. So from negative 100 to negative 200. All right, but I also don't want them in a big stream. So let's change the initial location, which is right there. And I'm going to say that its initial location, I select on here, I could say that it's from negative 1000, negative 1000, negative 1000, or under 100, to so now we're in this world of little snowflakes. Now you saw it disappeared real quick. That's kind of a thing that happens. You can see it's this nice square of snowflakes living, breathing, and dying. Underneath the required, I have to actually I have to tell it where the bounds are, because otherwise when the camera leaves the bounds, it disappears. I can show the bounds. Let's see, I can set fixed bounds, and then under spawn maybe particle pairs, rate scale, global spin rate. It's somewhere.
So the bounds is the camera leaving the bounds, not the particle leaving?
Yeah, it's the camera. The camera leaves the bounds, and the bounds are actually super small to start off with. I figured that out for you because I knew that we were having problems with that.
Yeah.
It's definitely in here on one of these, the first things, and it's just basically you make it the same size as your emitter. If you're changing the location, you have to. That's why when I go through, it just disappears and the camera goes to the other side.
I think that's how we balance the sounds.
Yeah, it doesn't work. I could hit bounds button and it should show me them, but they're super small by default. But anyway, let's put it in the world. Let's get some gratification out of this. There we are, guys. Loading from little laptop. Let's go and see how they look. So we can see the post-processing doesn't do particles. We have to change the processing order in these materials, I think, to be able to see the particles within those. But we unselect them and hit play. There we go. Comic Sans all in your face. Yes. And that's actually, yeah, just a balance thing. We'll figure that out. So that was super gratifying. But maybe we don't want it to be a square. So let's go back into the particle system. Okay. Initial location. Anyway. So I'm now going to get rid of this. And we're going to say instead of being a square, we're going to say the initial location is actually going to be a sphere. So now I have a sphere, but they're all just coming down off that sphere, so we can't really see. So we want to add some attraction. So we're going to add gravity. And we're going to take away velocity. Well, we need to make that sphere a little bit bigger. Let's make it 1,000. It's got to be in an immersive environment. So now you can see I have a sphere emitter, and maybe my gravity needs to be stronger. So let's make that 100 and give it a radius of 1,000. There we go. Well, that wasn't what I wanted. I wanted 10,000. There we go. Well, that's pretty cool. Where are you all going, guys? Where are you guys going? Oh my god, it's black hole. Anyway. And so the last thing I'm going to show you guys today is one of my favorites. It's a little thing called vector fields. Vector fields are one frame of a fluid simulation. And if you can imagine, like, you're dropping a bucket of paint, and at one moment you say freeze, and you can see that some stuff is splashing against the back wall, some stuff is just hitting the ground, some of it's coming back up, and you paused it. Each of those motions is a vector. That is an X, Y, and Z direction that we can actually export in 3D Studio Max or Maya. You can export one frame and then import it to actually move your particles around. And then once you import these vector fields in there, you can rotate them and scale them dynamically so that they can change the direction of the particles. So I'm just going to search for vector fields in the content root folder. And I'll have to find it first, though. Miscellaneous, vector curve. Sounds physical to me, but it's not. It's definitely not sound. Blueprints, animation. Well, I guess it doesn't exist, so we can't do it. No, I just missed it. I wonder what a blue tilt. Yeah. Well, I made it up. It was like this dream I had last night. Because of that sending, let's close this. And save this just in case. Let's open that up again. And I know where they are, so I'll just go find one. So we're going to open a level, and we're going to choose effects, which is spelled with an E, effects. And this is all the particle systems that come with the constant example, and we're going to find a local vector field. So you kind of get the idea right here. But I'm going to go and steal it, find my vector field. Go in here, then find the vector field. And there it is, hiding out deep in the catacombs. Migrate it to, this is week 10. Week 10 content, great. And then I'll close this. Migration successfully completed. And we'll open up our particle system again. And I'm going to add in a vector field. By selecting on there, I can find it, and it's the only one I have. So now, these guys are going to I'm going to take away a little bit of that gravity. In fact, I can take away all the gravity. And then I'm going to scale this guy up. Negative 1,000 to there it is. Let us say view and view vector fields. These are the tiny little arrows that I was talking about. I just need to get this thing positioned correctly. Just make it 100. By 100. By 100. And what's cool about local vector fields is that, let's move it down a little bit first. Too far. You can say the intensity, how much do you want them affected. Now this is vector math. You're adding the vectors to the vectors they already have. 10. And you see they're now a little bigger. Now they're shooting out. following the vectors. And to make things cooler, we can go to the vector fields, and then we can add a rotation or a scale or a rate. And then I can tell it to rotate at least 10, just 100, 100. Let's see. This is the initial. I want a rotation over time. Rotation rate. And then now I can just tell it to kind of rotate over time. It's a very sensitive value. So as it moves, it does more vector math, and it moves the vectors on top of the vectors. And I turn it off, and you don't see what's happening. Right? It's just a thing that you can kind of gather that there's some sort of nuance there. Maybe fling them out into space a little bit better. And now we have a sun tearing apart at ease. Yeah, because it's the natural simulation of what fluid did already that it kind of makes sense. It's not a bunch of vectors pointing at each other. So we couldn't see it because we were having some issues with maybe too many E's. Let's take away some of the E's and get this down to maybe just 100. And then we'll turn it on. So they have an initial velocity, and then there's a velocity that's set in time, or set in space, and then that velocity is also being moved a velocity as well. So there's 3 different velocities that are affecting every particle at any time. If I take off the rotation rate, and we just come and find one, these guys are just finding these little paths that the fluid simulation did. The vector field itself, I found that in another project. There's definitely tutorials for making your own stuff. Like I've used a suction one. There's a great selection of 50 vector fields in the assets of the marketplace, and they're really fun for making really effective. Like this is cool, like little neural net of like little ships. You can actually use particle fields, particle emitters to emit meshes, and that's how they do cars and spaceships. And they're just sending out vehicles, like an array of 10 vehicles, and then you can make them kind of curve around things and do some sort of weird weaving traffic flow.
This is just an example of one.
There can be, yeah, a fluid simulation. You can export a vector field of however long that simulation. It takes a long time to still do those, but if you had like 200 frames, you can have 200 different vector fields. Or we find the one perfect one where it splashes perfectly and it does the thing you want it.
This is all based in the particle system. It's not like a processing queue in the real-time world.
No, this is a local vector field, so this is only local to this particle system. If you want to have all your particle system be affected by a global, there's a global vector field. You just drag it in there, and every particle system will swirl with each other.
Do you only apply to particles, or do you apply to like the physics and gravity systems?
I haven't tried. That'd be something. You can also so emitters could be a bunch of emitters that are affected, and they can all have different properties. But you can also have, I could take this emitter, and then I can like copy and paste it, and then have a different like just change it slightly and have one have a faster initial rate and have one, and you can have this whole row of different things within one particle system and do the vector fields here, or you can have it so things happen globally in the world. If I go back, like I closed it, but if you go back to the content example, I'll save this, and the 2 seconds left we have, I'll go back to the content examples. and we'll see that right next to the local vector field was the global vector field. Using the same vector field, but it was just in the scene itself. So this actually just lives in the world. And, you know, come in here, steal it, just set up something in this world, and then, you know, see if you added I don't think it's a wind source. Like, I know there's a thing called wind that you can put into the world that would affect physics actors. I don't know if you can put the wind on a vector field. Usually, I think it's a unidirectional thing. Cool?
Cool.
So guys, do read about the homework. We'll do a little catch up on the video stuff. Book the room this weekend, and